Hey everyone. So, we're in this wild time where it feels like a new AI model drops almost every single week. It's exciting, but it also brings up a huge question. How do we actually know which ones are any good? Today, we're going to get into the surprisingly tricky world of AI evaluation.
So let's just put the question right out there. How do you grade an AI? I mean, it sounds like it should be simple, right? But it's honestly one of the hardest problems in the entire field. We see all these leaderboards and benchmarks, but what's really going on behind the scenes to decide who's at the top?
And the stakes here are getting incredibly high. This quote just nails it. As these models get more and more powerful and woven into everything we do, the consequences of them being wrong, of them spitting out confident nonsense, become way more serious. Good evaluation is basically our only line of defense.
See, the fundamental problem is this. For creative stuff, like writing an email or coding a new feature, there isn't just one single right answer. It's not like a classic machine learning problem where you can just check a box yes or no. And that's exactly why we've had to come up with a whole new toolbox for grading these things.
Okay, let's dive into that toolbox. We're going to start at the very foundation with the really mathematical metrics. These are the ones that measure how well a model just understands language, the basic patterns. They're absolutely crucial for figuring out how these systems are actually working. First up is something called cross-entropy. Now, the easiest way to think about this is as the model's surprise level. A really good language model is just less surprised by the next word in a sentence because it's gotten really good at predicting it. So, a lower cross-entropy score, it just means the model has a better grip on the language. And building right on top of that is perplexity. So, if cross-entropy is about how hard it is to predict the next word, perplexity tells you how many different words the model's kind of hesitating between. A lower perplexity means the model is way more confident, way less, perplexed about what should come next. And what's cool is how practical this is. I mean, look at this. A model's going to have a lower and better perplexity score on something structured like HTML code because it's just more predictable. And if you give it more context, a longer piece of text, it also gets less perplexed. It's a really versatile metric. Right, so here's the catch. Perplexity is awesome for measuring how well a model gets language, but it tells you nothing about whether an answer is actually helpful or true, or if it even works. So now, let's get into the methods that try to judge the actual quality of the final output. And really, this is the gold standard. Functional correctness. Does the thing the AI made actually do the thing it was supposed to do? This is easiest to see with code. You can just run the code against a bunch of tests. It's black and white. You get a clear pass or fail. It either works or it doesn't. Simple. But for things that aren't code, it gets tricky. You might try comparing the AI's answer to a perfect reference answer. Lexical similarity just counts matching words. It's super brittle. It's the kind of thing that can't tell the difference between let's eat grandma and let's eat grandma. Oof. Semantic similarity is way smarter. It gets the meaning, understanding that how's it going and what's up are basically the same thing. But even semantic similarity isn't perfect. So the industry has turned to this really powerful, kind of messy solution, using a super capable AI model to act as a judge and grade the answers from another model. This lets you do subjective evaluation, but at a massive scale. But of course, there's a huge catch. Your evaluation is only as good as your judge. The scores you get completely depend on which AI you chose to be the judge, and, this is super important, the prompt you give it. This whole approach opens up a brand new can of worms. And here are the big three biases you have to watch out for. Models often have a self-bias, where they just like answers from their own family of models. They can have a position bias, where they just tend to prefer the first answer they see. And they often have a verbosity bias. They think longer answers are better answers, which we all know is definitely not true. So all of these problems bring us to a much more modern way of thinking about this. What if we just stopped trying to give everything a precise score? What if instead we just had people pick a winner? This is the simple but honestly revolutionary idea behind platforms like the chatbot arena. Instead of asking some confusing question like, how good is this on a scale of 1 to 10? It asks a much more human question, which of these two answers do you like better? The whole process works like a giant tournament. You show people two anonymous answers, they vote for the one they prefer, and you do this thousands, even millions of times. Then you use rating systems borrowed from the world of chess, like the ELO system, to turn all those individual head-to-head matchups into a ranked leaderboard of all the models. But there's a huge asterisk here.
This whole crowdsourcing thing is amazing for general chatbot tasks where anyone can spot a good answer. It totally breaks down for highly technical questions. If a user doesn't know enough to see that an answer sounds plausible but is actually wrong, they might just vote for the wrong one.
So, to wrap this all up, you should really think of AI evaluation as having a toolkit. If you have tasks with a clear right or wrong, like coding, use exact evaluation. For other stuff, similarity metrics can give you a rough guide. If you need to scale up your feedback, use an AI judge, but just be super careful about those biases. And finally, when what you really truly care about is just what humans prefer, use comparative ranking.
And that leaves us with this final, kind of mind-bending question for the future. As these models get smarter than us in more and more areas, becoming superhuman, how will we even know what a good answer looks like anymore? Who or what gets to be the judge then?